Assalamu alaikum everyone, welcome to another video of CSE320 network communications or data communications. And today we'll be going through an easy topic which is known as DNS, and we'll be talking about application layer a bit as well. So without any delays, let's just start. So as a revision, a DNS server is the domain naming service, right? So and here we are using SMTP client. So SMTP stands for Simple Mail Transfer Protocol. We use this protocol to send emails, and this is a mailing protocol, right? And DNS, you already know, that domain naming system, which is used for naming the web page and giving a domain name. So that's the idea. And here you can see an example. For example, if you have this, and the idea over here is DNS is not only used for web servers, but also it can be used for email in SMTP. So user has this email, which is actually a person@wonderful.com, which is not a normal address, which is an easy, readable, understandable domain address. So the SMTP client receives that and he sends this to the DNS client, because he says, okay, this what you're sending is something of a text. I don't know what it is, but I know that you named it, so can you tell me what it is? And the DNS client deals with it and then translate and says, okay, this is what I actually mean. I gave this because it is understandable. So, and this is the real address, 200.200.200.5. So this is sent back to the SMTP client, and then the client says, oh, I see, so this is the address. Okay, then I'm sending it to the transport layer. I found the address. So when I'm typing this in like compose of Gmail, and when I compose this process takes place and the file is sent to this address through the client. And all of this work I did is in the application, presentation and session layer. So they're all involved. So mainly it's actually the application layer. Presentation and session layer, actually it's argumentative because you don't always need sessions. You have one session and you have some presentation work, translation. That is actually a part of application layer. So let's consider application layer for now. So let's move on to the next part, and we'll be talking about namespace. So to be unambiguous, the names designed to machines must be carefully selected for a namespace. So just like we said that a namespace, what is the name? Why do I need a name? The names assigned to machines must be carefully selected from a namespace with a complete control over the binding between the names and IP addresses. This is the point. So you have this address of something called 12.17.19 and something, so goes on. Is it possible to remember each of these codes for every single website? I can easily remember, okay, fb.com, YouTube, and there's, there was at least at a time, what's it called again? MySpace maybe. And then I have Google. Okay, these are easy. Can I memorize 4 different these weird codes? I can, but why do I have to do that when there's an easy way? So that is when a domain name shows up. So this is why we need this. And there are some specific facts about that. So first thing I want to show you, let me put my pen in. To have a space, a domain name space was designed, and okay, this is not in an inverted tree structure with a root at the top. The tree can have only 128 levels, and of course the level starts from 0 to 127. What does this tree mean? We're gonna see that now. Okay, just understand that there is a domain name space which is used for domain names. Okay, here we have the tree. So we start, this is very common. You all, oh come on, you all, seriously? So we all know this .com, right? So you have something .com, but not necessarily every time a website ends at .com. sometimes it may continue further to .com dot, you know, a slash, and it may go to, what can I say, class 1, and there could be many classes, so it could be section 3, there could be a morning and day shift, so there could be morning, and this goes on. So this is the idea. So there, from .com there is another, and from that there is another, and from that there is another, and from that there is another, from that there is another, and so it goes on. So this is the idea of domain name spacing. Okay, let me turn off the connection. That should stop this annoying message of license expired. Okay, so that goes on. Now let's see domain names and labels. So here is a real example of how it can continue, and with the labels. Okay, so let's see what we can do over here. So this is the root address, so it could be anything, so it's not shown, not necessary actually. From that we have .edu, which is a domain name which stands for education. Okay, that's a label, edu. Then we have fhda.edu. This is another category of, you know, okay, education of fhda. So there's another label. In the same way I can add another, which is atc, and then I can add another, which is challenger. So there could be an edu, there could be a fhda, and that can lead to an edu. There could be a ATC, which have many divisions, and one of them is FHDA, and then one of this FHDA is edu, something like this. Okay, so we already know this, right? So I told you that there's an example that you can have a website like tree dot, I don't know if this is English, 3, and you can say herbs, and you can say spicy. I'm just making it up, guys. I don't know if it makes sense or not. Just try to understand there could be subcategory. That's what we're trying to go at. That's where we're trying to go at. So moving on, and now domains. In this way there was .com also, right? And similarly .com also had some sub labels. So in this way every single domain can have labels, and more labels and more labels. So that is what we are trying to clear here, that this domain naming is not as simple as it sounds. It could get complicated depending on our needs. Now there is a matter of distribution of namespace. So let's read it out. So we cannot, like, how many web addresses are there? Can a computer, a super duper computer, it still is one of them efficient to keep all these thousands of addresses, millions and millions of them, domain names? Is it possible? No, it's not. So we'll be dealing about distribution of this domain namespace from now on. So consider that there is a root PC for root server. Okay, so this is the main root server, and then I divide a computer or a server for each of them. So this is for .arpa, this is for .edu, this is for .com, and this is for .us. And .edu has all under these, but if we go to further details for FHDA, for example, we had ATC, that is distributed to another server. So by dividing these servers, we can reduce the pressure on this root server, and also we can make it very easy and accessible, and of course it will work well. If you have all in one place, that won't give you a good result. There's a thing called load, so one cannot possibly take that. So it's always better to distribute. So this is the idea of distribution. If you want a drawing, then which color should I pick? Red. So this is where the thing started, and then it divided into 4. You can already see it, right? Divided into 4. And then if you want, okay, from edu I want FHDA, so this server has this is connected to this server, and then again this server is connected to ATC, something called ATC, and then it is also connected to something called, I don't know, maybe FHD or whatever. FHD is too similar, okay, FHD or whatever. So this goes on, and each server will have control of each domain level, so this makes things easier and also it ensures that they work well. Moving on, now we have zones and domains. So this is the zone, main zone, right, .com, because that's where you're studying from, and then you can move on to domain, zone and domain, and these are has all the domains. This is not necessary actually, we'll be skipping that. And you do understand that those sub servers, they must have a name, so they're called secondary servers, and the one at the top is the primary server. Okay, so the secondary primary server loads all information from the disk file, and the secondary server loads all information from the primary server. So you start with .com and it starts from the disk file, and then the further servers are maintained by those servers themselves. So these are the secondary servers, they load all information from the primary server. So if you are trying to reach ATC, it will load its files from FHDA, and then FHDA will load from edu, and then edu is the primary root server. So this is the, I don't know if it's English, but this is the idea. And this thing has a term in the secondary download information is called zone transfer, which is not necessary actually, but still, since it's there, might as well just do it. So we'll be moving on to the next slide, and DNS in the internet. Okay, so like we said, that DNS is not necessarily only in the internet, it can also be in various places. So DNS in the internet, that's the thing we're interested in. We don't want to know what the other uses are for now. So DNS is a protocol that can be used in different platforms in the internet. The domain namespace tree is divided into 3 categories: generic domains, country domains, and inverse domains. So you cannot just make up your own categories. There are divisions. Country domains you already know, .bd, .us, I don't know, ing maybe, .pac or pac, whatever you call it. So these are country domains. Inverse domains, and then there are generic domains. We'll know about them right now. So this is the root, and then this is the head of everything, and then I can divide those generic domains, those country domains, and those inverse domains separately. So this also breaks the load of my work. So if you have .com at the root, then .bd is different, .gov is different, and there could be .home or something. Okay, so this is an example. So look, they've showed an example over here. So it started from the root, and then we had edu. There are many other domains, and they all have their own categories, just like this one. These all of them have their own categories. Okay, so we're talking about edu. It has FHDA. Then again, FHDA has its own categories, and then this has its own categories, and this goes on until you reach a fixed website, shal.atc.fhda.edu. This is the final website, and to reach here you have to go through 1, 2, 3, and 4 domains. These are known as generic domains. So which are the generic domains? These are the generic domains. So let's move on and have a look. Some generic domains, examples of some generic domains. So many of us know them already. .com, the most popular one. Maybe since you use the internet, you have noticed that. .edu, if you're reading at this, if you're watching this video right now, you probably know what .edu is. .gov if you're from BD and some other countries that are government obsessed, then you know this already. .info, these are common ones, and .net is also common. So these, and .org, these are common generic domain names. So we'll not be talking about that, it's not necessary, you already know this stuff. So let's skip this and move on to the next thing. This is also very common. So you have these country names and you can easily use that. For example, we have google.com.bd. Then we can move to .k, then .carpet, and this goes on. So these are country domains. So you have France, you have, I don't know what this is, and I don't know what this is. Even if I know, I don't want to guess. So you can, and there's BD, of course. There's our own country, and then there could be Ind also. So these are some examples of country domains, and they're literally what they mean. Country domains means domains of countries. So for each country there could be a domain. So that's country domains. And now let's say something new. Inverse domain. Okay, what on earth is an inverse domain? So an inverse domain could be something that looks like this. And what is this, a country? Of course it's not. Is this any normal name? In add 1323445? No, it's not. So if you are not getting, okay, I have no idea what this is, that is probably an inverse domain, because you have some fixed generic domains, and then there are country domains that you know, BD, US. But if you see a domain that makes no sense, kinda, but they have purposes, so maybe it means nothing to you, but to someone this is actually what they need or something, you know. So that's the idea. So that's all. And that someone could be maybe someone who works in a, what am I drawing? Oh, come on, is this an arrow? Oh, it looks like a guy with a gun. Anyway, so that could be someone who knows this, and this could be the look of the address, which kinda doesn't look like a real domain name, and you could be wondering, okay, what's the purpose? But there is a purpose. So those are inverse domains. So for revision, there are generic domains, there are country domains, and there are inverse domains. So that's all for domains. And now DNS messages. You have, this is just very simple, just for knowing. You have query and you have response. So that's as simple as it is. For something to work, you need two sides. So one side will do the querying and the other side will respond. Okay, this is what you are querying for, and this is the answer. They have the same format, and they have the header and question records. And you know, these are just reading stuff. You don't actually have interest in this, and we know how it works. But we'll be looking at the structure now. So the common thing about queries, of course, what do you mean by query? Query means, okay, I want to know something, so it will have a title, which we call header, which has some stuff, and then will be, of course, query. So the question will be there, and then the header and this question will also be there, but also there will be some answers. That will be authoritative section, and there could be an additional section. Okay, you want some files? Okay, I'll send it to you. Okay, you need this, you need permissions, I'll send it to you, and you need the answer, this is the answer. So this is the format of, you know, DNS messages. So this is query and this is response. Guys, pardon my drawing, I have no idea why my mouse is not doing well today. So just imagine what I'm trying to draw. And then we have the header format. Okay, this is something we might have a look at. Header has two parts, identification and flags, and then each of them has this. Identification has the number of question records, number of authoritative records, and the flags have answer records, additional records. And you already know the division. If you don't, let me show you again which belongs where. Here is the authoritative section, additional section, answer section, and question section. These four things are included in the header, and the numbers of them. So number, the header has these numbers, okay, for the process to work properly and to ensure that the right message is received and everything is okay. So types of records, if someone asks, it is easily have two response, a question record and a resource record. So questions records are used in question section of the query and response messages. The resource records are used in answer, authoritative and additional information. So you can just simply make it simple by using the question record is for the query section and resource record is for the answer section. So this is just as simple as it sounds. Okay, let's move on. Registers. Okay, this is some. Now use your English knowledge. What do registers do? They register, right? And okay, so maybe now 10 years ago there was not a website which was known as DRAS, right? Could be, I don't know. 10 years later DRAS showed up. Okay, let's say 20 years ago DRAS wasn't there. 20 years later DRAS showed up. So how did it appear? Who added this? How did it reach the internet? That's where these registers show up. This is done through a register, a commercial entity accredited by ICANN. You probably know this by now from the second video. A register first verifies that the requested domain name is unique, because you cannot have, if you have another DRAS and there are two websites which are called DRAS and you type them and the domain server sends it, the HTTP server sends it to the DNS. Okay, HTTP sends it to the DNS and the DNS says, wait, hold on, how can you have two? Because this has one address and this has one address. Which one will I send you? And then HTTP goes crazy, or the DNS goes crazy, and then the thing is messed up. So you cannot have similar names, so it should be unique and then enters into the DNS database. Of course, that's not for free, since anyone can reach it and it's on the internet. A fee is definitely charged. So that's the idea. And then we have dynamic domain name system, DDNS. There is another system of domain name. You cannot just name anything you want, So this DDNS works for you to create a good name, and and the DNS master file must be updated dynamically. So the DNS file is updated by the DDNS, and so it is devised to respond to this need. Okay, so what's the work of DDNS? If I ask you, dynamic domain name system, what does it do? It does the updating of the master file. And so if you wanted more details, then when a binding between a name and an address is determined, the information is sent, usually DHCP, to a primary DNS server. The primary DNS server updates the zone. You know the zone, right? .edu. So the zone is updated and the secondary servers are notified either actively or passively, depending on the server availability. So this is how DDNS helps us. This is just for knowledge and further queries. So we'll be learning more about these things in the future, inshallah. So let's move on and explore encapsulation. That's the right, I told you. So DNS can use UDP or TCP. Okay, now do we know what these terms mean? UDP and TCP. First thing is, these are both protocols. Both of them are protocols, two protocols, but for now we don't know what they mean or what they're used for. So we'll be doing this in the next video, and let's stop it here, and let's not talk about UDP and TCP now. We'll be talking about that. Let me just tell you a hint that these are two protocols, and their server is port 53, as they say over here. You already know what port is, right? In the last video we did port. UDP is used when the size of a response message is less than 512 bytes. So we will know about UDP and why UDP is not reliable, why TCP is reliable, and stuff like this in the next video. So let's not read about these things now. Let's wait for them and we'll know them soon. Today our topic was DNS, so that's the end of DNS. And DNS can use services of UDP or TCP using the well-known port 53. So if DNS wants access to these two servers, which does the work of, how should I say, transporting these two transport layer protocols, then DNS needs to use the port number 53. So we'll talk about these UDP and TCP later when we talk about transport protocol. For now, let's say goodbye. Happy surviving. All you need to do is survive. Thank you.